So we've just finished talking about independent compound events. There is another type of compound event, and that is dependent compound events. So a dependent event or dependent events are events if the occurrence of one of the events does affect the occurrence of the other event. So what do I mean by that? Well, similar to the independent example, I'm going to create something slightly different. Rather than have two separate boxes with these marbles, let's just say that this is one box. Now check that this is correct on your notes. I think there could be an error in some of the printing where these are actually two separate boxes, but I want to consider these one box with all of these 8 marbles. What are the chances if I pull one marble out of the box, remove it, and then a second marble out of the box? What are the chances what are the chances that the second marble is red? Think about that for a second. Pull 2 marbles out, what are the chances that the second one is red? Well, I mean, it depends, right? I could pull the first marble, and that could be red, right? There's nothing wrong with the first marble being red. And if that's the case, then now there are 7 total marbles left. That's the 7, and only 2 of those remaining are red. But that's not the only way this could play out. I could also have pulled the first marble and it not be red, and in that case, there are still 3 red marbles out of 7. So really what we're trying to say here is it depends on what the situation is, whether or not I want to figure out the chance of pulling out the second marble as red. So how do we talk about this? In general, if I have 2 dependent events, these are events that actually affect each other, then the probability that A then B occurs is given as the probability of A by itself times the probability of B given that A has occurred. So what do I mean by that? Well, let's see what I mean in this example. Here I've got a box of 4 red and 2 yellow tickets. So one thing to keep in mind is there are 6 tickets at the start. 2 of them are randomly selected from the box, one by one, I shouldn't say on by one without replacement. So what does that mean? That's kind of like the marbles. I'm going to pull out a ticket, and then I'm going to pull out a second one without replacing the first one. I want to find the probability that both are red. So what I'm looking for is the probability that I draw a red, then red, and that's going to equal the probability of drawing a red times the probability of drawing a red given red. And really this just means I've pulled out, I have to kind of consider what the new sample space is at this point. So maybe I'll even highlight that. This piece right here has a new sample space. So the probability of drawing a red, well, if I have 4 red tickets out of 6 tickets to start with, then the probability of drawing a red ticket at the start is 4 out of 6. And I'm going to multiply that by my new sample, using my new sample space. So the probability of drawing a red given I've pulled out a red, let's think about what is remaining. There are now only 5 tickets left in this, box. Left in this box since I've taken one out. And of those 5 tickets, let's think about how many of them are red. Well, not 4 anymore since I pulled one of them out. So now there are 3 red tickets remaining. So right now, when I multiply these two things together, I get a total probability of 12 over 30, which reduces down to 6 over 15. And actually, I can reduce that one more time to 2 out of 5. So this reduces down to a probability of 2/5, which is equal to 40%, or 0.4 probability. So this is, again, once I take the initial sample space of my probability of the red occurring, I need to kind of recalibrate my sample space, recalibrate the number of possible outcomes for success, and use that as my second probability. Sometimes it kind of helps to visualize this, maybe drawing something or thinking about what's actually going on in this problem. So why don't you try an example like this? Here we have another box, and again there's 4 red, 2 yellow tickets, and I want you to find the probability that the first one is red and the second one is yellow. So we're going to use this generalization up here again. Pause the video, give this one a shot. All right, so the answer for this one, I want to multiply the probability of the first ticket being red times the probability that the second is yellow, given that the first is red. So 4/6, it represents how many reds out of the total 6 tickets. 2/5 represents the number of yellows that remain out of the 5 left, since I have removed the first ticket. Multiplying those two things together gives me 4/15.